Hello, and welcome to the final lecture in our series on systems engineering, where we start to look at the systems engineer. My name is Tim Kerby. I'm the CEO of Edinburgh Systems Ltd, a consultancy specialising in systems engineering and product management for technology companies. To start with, we need to think about engineering systems or systems engineer. Now, lots of engineers have learned to build systems by integrating the component building blocks. It's like taking your Lego and building something out of it. They're not necessarily systems engineers, although we see the job title used by people who work on systems as well as actual systems engineers. A lot of engineers don't have exposure to the best practices for system design or the formal discipline of systems engineering. And systems engineers are often mandated by standards to engineer the systems safely and securely. There's really three things to a systems engineer. They need their systems thinking and systems engineering ability, their technical knowledge, and their leadership skills. Technical knowledge and leadership you can develop over time. The systems thinking and systems engineering ability, particularly the systems thinking as it's a way, an approach of doing things, is harder to develop later in a career, and I'd encourage people to start looking at this early. If we look at a systems engineer versus a design engineer, for instance, the design engineer has a deep specialist knowledge. We call these eye-shaped people, that they have a lot of depth in a particular area. A systems engineer, on the other hand, has a broad knowledge across a wide range of disciplines, and they have their systems expertise. They're really a good facilitator. So the systems engineer is multidisciplinary. They might be able to apply their skills to lots of different areas. I say to people I work with, I might not be the best person to design something, although given time I could, but I can analyze your design, I can understand it, I can assess it, and I can see whether your solution is the best solution or whether perhaps something else that someone else has proposed is a better alternative. As part of this, the systems engineer is a really good leader and facilitator. They facilitate the different design engineers to get the best out of them by providing them with the right problems to solve, whereas the design engineers are often the leading experts in their specific technical areas. So, as I mentioned, systems engineers are often good at putting together quick prototypes, but they're not the experts in detailed design. Some examples here. On the systems engineering side, we have modelers, functional safety managers, validation engineers, system architects, design engineers, you have your mechanical engineers, algorithm designers, FPGA engineers. These describe the sort of roles and sort of jobs that different people might be doing. If we look at the role of a systems engineer and how these three areas are applied of their technical knowledge, leadership skills, and their systems thinking and systems engineering ability. They work throughout the whole system's lifecycle and throughout the design. Early on, they're responsible for helping understand the problems, for product management, requirement solicitation, and looking outside the system boundaries and how that system operates in the environment. As that moves on, they can work to generate and select concepts, so carrying out functional architecture, concept generation, prototyping, modeling activities. They then can look at formal architecture, so system requirements, trade studies, designing the interfaces, putting together specifications, formal architecture, and some of the safety engineering activities in there. They then have a responsibility for verification and validation, so integrating the components in the system, putting together test benches, stakeholder acceptance, standards compliance, and they have responsibility for planning over the full life cycle, so support, documentation, upgrades, reuse, and disposal. Typically, I see system engineers tend to fall into two broad categories. Either they work on the front end up to system architecture and tend to focus more on bringing in the requirements, or they'll work more on the back end in terms of carrying out some of the design, the integration, the validation test. If we look at the proficiency for systems engineers, there's some good competence frameworks out there developed by Cozy. Here we have a graphic from the Helix project that looked at lots of different systems engineers in industry and what made them proficient. So you can see in here you have those leadership skills, so technical leadership and interpersonal skills. You have the systems thinking and systems engineering ability, so your mindset, your discipline, and some of the systems domain and operational context. And you have that technical knowledge, your general engineering, maths, science, and potentially some of that extends out into the system domain as well, of how that applies to the specific systems you're working on. But really key is some of the personal characteristics, so being inquisitive, ambitious, self-awareness, lifelong learning, and professionalism make good systems engineers, but also the characteristics of the organizations that foster those behaviors, so they're like culture, structure, values, and the appreciation of systems engineering. So systems engineers can grow their careers, and there's good potential for them to do so. If you're thinking about career choices, then why choose systems engineering? If you look at the data on payscale.com as senior engineering roles, taking a whole variety of different roles in there, there's about a 7% increase in salary for systems engineers versus other disciplines. If you're doing safety roles, that can be substantially more. Some of the most well-paid engineers I know as systems engineers work in functional safety. The skills are in really high demand. There's an urgent need here. We see governments putting out requirements for whole systems thinking recently for energy in the UK, for net zero, in the healthcare sectors, for autonomous vehicles and transport networks. There's a lot of demand for systems engineers. It's a very transferable skill. So you can apply systems engineering to products, to organizations, across different sectors, different disciplines, and it doesn't really go out of date as the technology changes. It enables you to continually learn, to continually move into different fields, and to follow your interests and your dreams there across those different sectors. Very people-focused. The answers aren't really in your office, they're out there with the customers and the stakeholders. So there's a lot of opportunity to travel as geographically distributed teams, and the opportunity to work with a whole variety of different stakeholders. And some of the most interesting products and projects involve systems engineers. So renewable energy, autonomous vehicles, robotics, space and satellite, medical technologies. There's a wide variety of things that you can get involved with, and it's a lot easier to change discipline as a systems engineer than it might be as a detailed design engineer. To summarize, systems engineers have the three key skill areas: their leadership, their technical knowledge, and their systems thinking and systems engineering abilities. Systems engineer has a breadth of knowledge and experience, and they can apply themselves to many different areas. The role applies throughout the life cycle, and a systems engineer may specialize in one area, such as architecture, modeling, or validation, either at the front end usually, or the back end of the system. To thrive, they also need the right organizational culture and support. And they have great career prospects and the opportunity to work on a wide variety of really interesting technologies. So thank you for your time. If you've got any questions or want to get in touch, my email address is here, and I look forward to hearing from you.